x1 prime, so we got this point E1, small e1, and at second price P1 double prime, the demand is x1 double prime, and we got this point. So small e1 is exactly the same point as capital E1. Small e3 is exactly the same point as capital E3. The only difference is this, that we have changed the vertical axis. In panel number 1, along vertical axis, we were measuring second commodity. In panel number 2, along vertical axis, we are measuring price. So if this small e1 and small e2 are joined, we got the Marshallian demand function, which is the ordinary demand function. So what this demand function is telling us? You can clearly see from here that this demand function is in fact measuring the price effect. It's measuring the price effect. So what this demand function is telling us, the change on demand, the effect on demand of a commodity due to change in the price with the given level of income. What Marshallian demand function tells us, the effect on demand of a commodity, the effect on the demand of a commodity, which is the price effect due to change in price of a commodity with the same income level. Okay, now in the same diagram, we will plot the Hiksian demand function as you did in your course of intermediate microeconomics. Now see here, if you compare the two diagrams, then in fact second diagram is the replica of first diagram, with only one difference, that in second diagram we have shown the Hiksian demand function as well. Okay, look at here. Price effect was from E1 to E3. Now you can see here that E1 is on the lower indifference curve. E3 is on the higher indifference curve. So utility level has gone up. As a result of decrease in price, the utility level is gone up. But we want to restrict the consumer to the same utility level. So for this, what we will do, the benefit which consumer got as a result of decrease in price, we'll try to take that benefit by shifting the new budget line parallel downward, such that the new budget line makes tangent to the old indifference curve. Now here you can see we plotted an imaginary hypothetical line. This hypothetical line is showing a decrease in the purchasing power of income, right? It's parallel to the new budget line, which means that the new prices are maintained, the new price ratio is maintained, and this red line is tangent to the old indifference curve at point E2. So you can see here point E1 and point E2 are showing the same level of utility because they are on the same indifference curve. So point E2 is taken in the second panel here, and similarly this point E2 is also taken in the second panel. In second panel we joined the 2 points and we got the red colored line. This is the Hiksian demand function. Why it's the Hiksian demand function? Because here the utility level is given. Utility level is given. Here you can see that prices have changed. So Hiksian demand function is also the function of prices. But the condition for Hiksian demand function is this, that utility is given. So if utility is given, it means consumers should be on the same indifference curve. So here you can see that E1 and E2 is written in red color and E1 is written in black color. These 2 points are on the same indifference curve. So these 2 points yield same level of utility. So Hiksian demand function is showing that the utility level is given. And look here, look at the Marshallian demand function. This is the Marshallian demand function. It's also the function of P1 and P2. But in case of Marshallian demand function, the income is given, price have changed. So Marshallian demand function, you can see from here that it measures the price effect. Okay, it's not written here, but you all know it very well, that movement from this x1 prime to x1 double prime is the substitution effect. You all know it. So it means that the Hiksian demand function measures the substitution effect. Hiksian demand function measures the substitution effect. Okay, now let me conclude the things. Marshallian demand function measures the price effect. Hiksian demand function measures the substitution effect. This is one difference. Marshallian demand function is that at which income is given, held constant. So they are also called money income held constant demand functions. Hiksian demand functions are those at which utility level is given, same indifference curve. So they are also called utility held constant demand function. Marshallian demand function is also the function of prices. Hiksian demand function is also the function of prices, but the third variable is different. In Marshallian, it's M, in Hiksian, it's U, which is given. Okay. Any question? Okay. One more thing. Now, in this particular diagram, wait, beta. In this particular diagram, we took a case of normal commodity. If you take a case of given commodity, then what you will find? You will find a positively Marshallian demand function. You already know it. I'm not going to repeat it. You have learned it in your intermediate microeconomics. And if you take a case of inferior commodity, your Marshallian demand function will be negative, but it will not be as flatter as this one. However, the Hiksian demand function, it is always negatively sloped irrespective of the nature of commodity. If you are doing a case of a normal commodity, if you are plotting a case of inferior commodity, if you are plotting a case of given commodity, in every case, in all the cases, the Hiksian demand function will be negative slope. So in other words, I'm saying what your teacher of intermediate microeconomics also told you, that substitution effect is always negative, irrespective of the nature of commodity. Ji beta, what's the question? Ji, question please. Any question? Aage chalo?
Excuse me, sir. Sir, when we are compensating the consumer, right? Now, do we have to compensate him with exactly enough so that he could purchase the bundle on the same indifference curve as before?
Actually, there are two approaches. Okay, the one which you are talking about is the Slutsky approach. Okay, and here we are talking about the Hiksian approach. In Hiksian approach, we compensate consumer in such a way that he is able to get the old level of utility, not the old consumption bundle. And in the other approach, we compensate consumer in such a way that he exactly go back to the old level of consumption bundle. There are two different approaches. In your course of intermediate microeconomics, when you were discussing the topic of decomposition or the breakdown of price effect into income effect and substitution effect, your teacher must have told you that there are three approaches. One is the compensation approach, which is this one. Other is the equivalent variation approach, which is the opposite of this one. And then the third approach is the cost difference approach, which is also known as the Slutsky approach. So you are talking about the Slutsky approach. Okay, so in nutshell, if you are asked to compare the Marshallian demand function and Hiksian demand function, then you know that Marshallian demand function measures the entire price effect. Hiksian demand function focus merely on substitution effect. Since substitution effect is always negative, so Hiksian demand function is always negative, irrespective of the nature of commodity. Marshallian demand function is negatively sloped for normal commodity and inferior commodity. However, it's positively sloped for the given commodity. Marshallian demand function is called the money income held constant demand function. Hiksian demand function is called the utility held constant demand function. Marshallian demand function is the utility maximizing demand function. Hiksian demand function is the expenditure minimizing demand function. Okay, now look here in this diagram, just to tell you, just look at this particular segment. If this E3 point is somewhere here, for example, then it means that this X1 triple prime will be here. Okay, and you will get this type of Marshallian demand function. That will be the case of inferior commodity. Still negative slope Marshallian demand function, but steeper as compared to Hiksian demand. And if similarly this E3 point goes here beyond E1, then your Marshallian demand function will be positive. You have learned all these things. If required, then I can send you the figures. Okay, so this is all about the derivation of the Hiksian demand function and a bit understanding of the Hiksian demand function. Now, we will take one numerical example And then on that numerical example, we'll apply the Lagrangian function. From that Lagrangian function, we'll work out the first order conditions, and then we'll simultaneously solve those workout conditions to get the Hiksian demand functions. So this is what we are going to do now. Okay, look here, this is one example. We took same example in case of Marshallian demand function. In our class, when we derived Marshallian demand function in class, we took the same utility function. That utility is equal to x1 square into x2 square. And budget line is always same. M is equal to P1 x1 plus P2 x2. But here, the behavior is different. Utility is the constraint. That's why I wrote bar on U. Bar on U means this is something which is constant. And M is not fixed, it's the objective function. So we worked out the Lagrangian function. You can see here, what's the Lagrangian function? We took the objective function here, which is P1 x1 plus P2 x2. अगर यहाँ पे तीन commodities होती तो plus P3 x3 भी आ जाता, plus the Lagrangian multiplier. Deliberately I wrote it with lambda prime just to differentiate this Lagrangian multiplier with the Lagrangian multiplier of utility maximization. Here came the constraint. You know that the constraint is equal to 0. If you take this x1 square into x2 square on the other side, then you will get this thing. So this is the Lagrangian function. Now we'll have to take the three derivatives. One is with respect to x1, other will be with respect to x2, and third one will be with respect to lambda prime. Each derivative will be set equal to 0, which is our first order condition. So here we did it. You can see here, look at the first line, equation number 1. The partial derivative of Lagrangian with respect to x1 is set equal to 0. When you differentiated this equation with respect to x1, that you know that the derivative of x1 is 1, p1 came as it is. The derivative of x1 is 1, so p1 came as it is. And then this lambda prime is there. U is the constant, its derivative will be 0. And here when you will differentiate it with respect to x1, you can see that this 2 will become here. So we have written it. And the power of x1 will reduce by one number. It is reduced by one number. x2 square will come as it is. So this is equation number 1. So exactly in the same style, we took the derivative with respect to x2. And finally, we differentiated with respect to lambda. It's missing from here. I think you can easily understand. It's curly L over curly lambda prime. It's just missing from here. So we got the three first order conditions. Now if we simultaneously solve these three first order conditions, we'll get the Hiksian demand functions. So you can see that from equation number 1, we derived the value of lambda prime. And similarly, from equation number 2, we derived the value of lambda prime. Since both are equal to lambda prime, so we can put them equal to each other. Any question? Any question? Okay. So what we did, we got a very simple example. In this example, the utility function was given to us, which was the constraint. We took it as a constraint. And then the objective function was expenditure. We took it as an objective function. We worked out the first order conditions. And now here we are simultaneously solving the first order conditions. From equation number 1, we worked out the value of lambda prime. And similarly, we solved equation number 2 for lambda prime. Now these two expressions are equal to lambda prime, so we can put them equal to each other. So we put them equal to each other, and now a simple simplification here. The simplification gave us this result. You can see here that we took prices on one side and x on the other side. The 2 of numerator and 2 of denominator can be cancelled out with each other. And similarly, in numerator we have x1 here. In denominator we have x1 square. The square will be cancelled out. And similarly here we have x2 square, and denominator we have x2. The square will cancel out. We'll have this thing. And from cross multiplication we can have here. So we worked out an equation for x1. We worked out an equation for x1. But this is not the Hiksian demand function, because we know that Hiksian demand function should be the function of prices and given level of utility. It's the function of prices and other commodity. So now what we'll do, we'll substitute this Hiksian demand function in our third equation of first order condition. So you can see here, this is the third equation of first order condition. So in place of x1, we'll substitute the equation number 4. So we are substituting equation number 4 in 3 and we got this thing. Now you can see here that equation number 3 is this. In fact, it was u bar minus x1 square into x2 square equal to 0. So I just took x1 square or x2 square on the other side, it became positive. Now in place of x1 square, I wrote its value from equation number 4, and then after some simplifications we got x2 power 4. You can see here this is x2 and this is square, so it will become x2 square. So this x2 square and this x2 square will make it x2 power 4. This is p2 square, and here this is p1 square, which we wrote it p2 square over p1 square. So x2 raised to the power 4 is equal to this thing. So it means we don't need x power 4. We need simple x. So we will take its under root for 2 times. When we take its under root for 1 time, we'll get the x power 2, and then we'll once again take the under root. So this is what we have done here. You can see here we took the under root on both sides, taking square root on both sides. When we took square root of this side, it became x square. And when we took square root on this side, it's u bar a constant, it became under the square root. And this p1 square over p2 squared, this p1 square over p2 square came as it is. So here the squares are not, this one is not there. ये काटा हुआ है, अच्छा? ये p1 की power 1 है, इसमें there is nothing here. क्योंकि जब आपने square root लिया तो खत्म हो गया. So here we got x2 square. We need x2. So once again, we again took the square root. And this is what? U bar under root. It means u bar power 1 by 2. तो इसका जब दोबारा आप अंडर रूट लेंगे तो इट विल बिकम u bar power 1 by 4. और जब आपने इसका अंडर रूट लिया तो ये बन गया p1 over p2 power 1 by 4. So this one is solved for x2. If you put it back in equation number 4 and simplify it, you will get it for x1. So we got the the Hiksian demand functions as x1 is equal to u power 1 by 4 into p1 over p2 power half, and then x2 is equal to u power 4 into p2 over p1 raised to the power half. So you can see here that both the Hiksian demand function are the function of the given level of utility and the prices. So this is all about the derivation of Hiksian demand function. Now the floor is open for questions. If you have any questions, I'm available. If you want me to go back on the previous slide, I'm ready for that. Ji beta. Any question, please? Okay. No, I'm not giving you any assignment here. जी.
सर ये जो आपने स्लाइड जरा पिछली साइड पे आएंगे सर. तो यहाँ पे फर्स्ट जो पिक्चर है उसके अंदर जो आपने x2 की पावर 4 का जो अंडर रूट लिया है, तो नेक्स्ट पिक्चर में अंडर रूट यूटिलिटी कांस्टेंट जो है उसके ऊपर तो कहते हैं स्क्वायर रूट आया है, लेकिन आपने p1 का स्क्वायर और p2 का स्क्वायर
खत्म हो गया ना बेटा. जब आपने अंडर रूट लिया तो स्क्वायर खत्म हो गया ना.
अच्छा, ये आपने
नहीं यहाँ पे
क्या बात. ठीक है,
p1 के स्क्वायर पे p2 के स्क्वायर का स्क्वायर खत्म हो गया ना.
ठीक है,
तो वो स्क्वायर था नहीं उसके ऊपर, इसलिए उसके ऊपर हमने अंडर रूट लिख दिया. अंडर रूट का मतलब है पावर 1 by 2. अच्छा, अब मैं आप लोगों को सजेस्ट करूंगा, इट्स नॉट एन असाइनमेंट, इट्स जस्ट अ सजेशन दैट आई गिव यू दिस यूटिलिटी फंक्शन u is equal to x1 square over x2 square. So it will be good if you do it for any other utility function. Say for example the same one which I gave you as an assignment in my previous class, जिसमें मैंने आपसे कहा था कि Hiksian demand functions वगैरह derive करें. So you can take it as x1 power alpha into x2 power beta, and then you can solve it. So that is all for today. If you have any questions, any suggestion, then I'm here to answer your queries.
No, sir, thank you.
अच्छा, छोटा सा मैं एक एक्सपेरिमेंट करूंगा अगली 2 क्लासेस के लिए, सिर्फ 2 क्लासेस के लिए, इससे ज्यादा के लिए मैं नहीं करूंगा. ठीक है, मैं इस गान को बनाऊंगा इस ग्रुप का ओनर.